Okay, so just to kind of recap, we're dealing with transverse and longitudinal waves, and we're going to be talking about how they move. So there's three different ways that you should be aware as far as how waves move. We're going to be talking about reflection, refraction, and diffraction. And so these are words that I have found over the years of teaching this that students easily get confused. But there are three different things that can happen to a wave that changes where it's going or how it's moving. And by the end of this little section, you should be able to compare and contrast these without any real difficulty. So let's start off with the easy one, the one that we are all most familiar with. And this is the idea of reflection. If you have looked in a mirror in the last 24 hours, you have experienced reflection. It is basically light going towards something and then bouncing off of it and heading back to you. And this could be light. It also happens with sound. If you've ever heard an echo, that is simply sound reflection. Or if you've ever watched like a water wave run into something and bounce off, again, reflection. Anything where we can describe something bouncing off of something else, that's what we're dealing with. So if a vertical surface is put in the path of a wave, something for it to bounce off of, the waves are reflected, and they are reflected at the same angle that they strike at. So if it's coming in at an angle, it'll bounce off at an angle. The angle that it hits the wall at is called the angle of incidence. So I like to say incidence sounds kind of like incoming. So it's the angle that the incoming wave runs into the wall at. And then it bounces off at what's called the angle of reflection. And the important thing to note, and it's like colored differently and underlined and everything, is that the angle of incidence and the angle of reflection are always the same. So if my angle of incidence is 25 degrees, my angle of reflection is 25 degrees. They are always equal. And you can see an example of how they are always equal in the lower left-hand corner of that slide. Give you guys just another couple minutes to finish that up. Probably not even, more like 1 minute. All right, so that's reflection. And like I said, that one's the one that most of us are kind of super familiar with. The second one is going to be refraction. And refraction is a little bit different. Refraction is what happens when a wave starts in one type of substance and then the thing that it's moving through changes. So we could do things like we could change the depth of water, and that changes the way that waves behave. We could change the thing that it's moving through, like a sound wave that starts by going through a wall and then goes into the air on the other side. So that little change in medium, or medium is the thing that the wave is going through, is what we refer to as refraction, and it changes the speed of the wave, changes how fast things are going. And if we just start to drag one side of the wave, it'll change the direction as well. But really what we're looking at is we're looking at the speed change of the wave. And so you can kind of see that example right there on the right, where we've got this piece of plastic that makes the water really shallow. And the wave kind of shrinks as it's going above that shallow part. It slows down, and then it goes back to being fast as soon as it goes back into deep water. So Milani says, so the closer the little waves, the faster, or no, so the closer the little waves are, the slower it's going. So yeah, shallow water tends to make things really slow. If you've ever been to the ocean and you've seen kind of like the big waves as they come in towards the shore, the problem is as the water gets shallower and shallower and the wave moves through it, the bottom of the wave slows down because of refraction, but the top of the wave is still moving at the speed it used to go. And so I want you to think about for a moment what would happen if all of a sudden I slowed down your feet, but the top half of your body was still going at the old speed. And you'd probably figure out really quickly you're going to topple over. And that's exactly what happens with big waves, is that when the bottom slows down, but the top is still moving at the old speed, they tilt forward and they crash. And that's what makes the big curve that surfers are looking for when they're finding good waves to ride. So that crash of the wave happens because of refraction, because the water changes speed, or the wave, I should say, changes speed based on the substance that it's moving through or the depth of the substance. Good. All right, the last one that we're looking at is diffraction. And I'm going to have Ms. Monroy explain diffraction.
Okay, so diffraction. The waves, as it says right there, waves will bend around the sides of an obstacle or spread out as they pass through an aperture or gap. The effect is called diffraction. So in diffraction, we can actually think of it, and Mr. Coltman gave this example earlier, think of it as light. So when we're in our rooms, and it's really dark in our rooms, but there's light outside, we notice that some of the light seems to peek in and brighten up the room. So it creates kind of a, like, the light peeks through the bottom of the door, causing waves. So in this case, like light waves to come into the room, causing diffraction. So as we said right here, waves will bend around the size of an obstacle and spread out. So even though it's very minimal and it's a very tiny gap, we can kind of just like peek through that. And that's what causes this diffraction.
So yeah, just diffraction, anytime you've got a wave that goes through a gap, it's going to spread out on the other side, and that's what diffraction is really doing. On the pretest, some of you might have seen there was like a question involving a boat. And it was a boat on the inside of a harbor. And if you've ever been to like a harbor next to the ocean or a large lake or something, sometimes they build these long walls in the water. They stop the waves from heading in, but there's always a gap so that the boats can get out. And so once the water passes through that gap, it's going to spread out on the other side. And that was the question with the boat on the pretest. So those are three different ways of having waves change the way that they are moving. So we've got reflection, where they bounce off something, refraction, when it changes what it's going through, and diffraction, when it has to go through a gap. On this next slide, I'm going to ask you guys to go ahead and click and drag those three words next to the picture that best describes that thing. And I'll give you 60 seconds to do that. All right, so if now that you've kind of figured out where things are probably are, here's the answers. Go ahead and check your own work and see how well you did. The first one is refraction. We've got deep water and shallow water. And you can see that the wave kind of bends a little bit towards the right because part of the wave starts to drag before the rest of it does. The middle one is diffraction. We've got sound traveling through a doorway. And then the last one is reflection. It's just going to bounce off of the ground and head back at the same angle that it hit the ground at. Good. And so those are the three ways, and you're going to be responsible for knowing how those three ways of changing a wave's movement work. It's going to be a fairly decent part of the upcoming quiz, so please make sure that you're familiar with it. Now that we're at the end of 5.1, we've gone through what the different types of waves, what waves are, and how they move. I'm going to ask you guys to summarize a few things. So the first question is, what are the main parts of a wave? The second question is, how are frequency and period different? The third question is, what are the two types of waves, and give an example of each? And then the last one is, a wave changes speed as the water becomes shallow. Which of the three wave changes is this describing? So go ahead and answer those four questions. I'll give you about 2.5 minutes to work on that. And then we'll come back together and we'll see how we did, and then we'll move on to our next activity. All right, let's go ahead and take a look at the answers for those four questions. First question, what are the main parts of a wave? I'll look for volunteers first, and then I'll start calling on people. What did you guys put for the main parts of the wave? Crest, trough, amplitude, wavelength. Good. All right, Isaac and Tyler both got it. You could have the origin marked as well. That's kind of the midpoint of the wave, but perfect. Good job. How are frequency and period different? Or what are frequency and period? You could have described them and it would have shown up. Okay, Nolani says frequency is how many waves go past in 1 second, and period is how long it takes for one wave to pass. Perfect. Realize that when you are trying to tune your radio in your car, you're trying to dial in a specific frequency. So for instance, 95.1 is like 95,100 hertz or something like that. Might be kilohertz. But you're telling your car a specific frequency that you want the antenna to tune into. So that's how frequency works. It's looking for something with 95,100 waves per second. All right, next up, what are two different types of waves? Give an example of each one. Well, we already know the two different types of waves are transverse and longitudinal, but did anybody come up with examples of each one? All right, Tyler's got this one. Transverse radio and light, good. Longitudinal sound waves, excellent. Sound and springs or slinkies are going to be the two examples that you are most likely to see if I ask a question about longitudinal waves. And then, yeah, radio, light, water waves, those are all good examples for transverse. All right, last question. A wave changes speed as water becomes shallow. Which of the three wave changes does this describe? So reflection, refraction, or diffraction. Which one is this? Refraction. Excellent. Yep, this is refraction. Good. We've got a wave that is changing speed because of a change in the thing that it's moving through. So this is definitely refraction. Excellent job, everybody. That is the last slide on 5.1. If you guys head back out of Canvas, you should find the ability to submit this. If you need to see any slides because you missed them, you can put that in the chat right now. Otherwise, I'll have this video posted to Canvas later today, so you can always check it out there. And with that, all right, slide 19. With that, I'm going to turn this over to Ms. Monroy, who's going to walk you guys through an activity where you're going to be comparing and contrasting some things.